over 3, s equal to ut plus half at squared, and 4, v squared is equal to u squared plus 2as. To derive the equations of motion, first we start by defining acceleration. So acceleration is the rate of change of velocity with time, which can be written this way. Remember, a is our acceleration. It's equal to change in velocity. This is final velocity minus initial velocity over time t. Okay, so now this is acceleration. Now we use this to derive the very first equation of motion. Now if you cross multiply this equation, what you are going to get will be v minus u is equal to at. That is v minus u multiplied by 1 here will give you v minus u is equal to a times t will give you 80. Now, you just use your simple algebraic method to rearrange the equation. So you can leave v on this side and move u to the other side, which makes it u plus at. So this is the first equation, call it equation 1. Now for the second equation, under uniform acceleration, average velocity is given as v. Let's call this average velocity given as v is equal to u plus v all over 2. So I use this to denote average velocity, okay? So which is u plus v over 2. U is the initial velocity, v is the final velocity over 2. That makes the average velocity. It can also be written as distance over time, okay? Velocity is also distance over time, okay? So which means that we can equate it together. U plus v over 2 is equal to our distance. We normally use s to denote distance when we are writing the equations of motion. So this will be s over t. Now, if you do a cross multiplication as you did earlier, okay, you see that 2 times s will give you 2s will be equal to t multiplying u plus v will give you u plus v multiplied by t. Okay, so if you make this s the subject, it becomes s will be equal to u plus v multiplied by t all over 2. So this is your second equation. Now let's go for the third equation. Let's derive the third equation. Recall that in equation 1, we arrived at this u plus v is equal to u plus at. Okay, if we do that, we'll let's substitute equation 1 in 2. This is our equation 2. S is equal to u plus v of t over 2. So now, instead of writing v here, we know that v is equal to u plus at. So instead of writing v here, just put u plus at. So we'll write this as s is equal to u plus, instead of writing v, we'll say u plus at. Okay, now we'll still multiply by another t here, all over 2. Now let's rewrite the equation. S will be equal to, now u plus u is 2u plus at. Okay, we are still going to multiply with another t there over 2. Now let's expand it further. So now this t now multiply this 2u and also multiply this at. So that gives us 2ut plus at squared, okay, over 2. So if you do that, let's separate the terms and see what it gives us. S will be equal to 2ut over 2 plus at over 2, at squared over 2 actually. So that will cancel these two. These two will cancel these two. So you are left with S is equal to ut plus at squared over 2. So this is exactly what I meant. 2 will cancel these two, leaving you with ut plus at squared over 2. So S will be equal to ut plus at squared over 2, or S equal to ut plus half at squared. So this is your third equation, equation 3. Now for the fourth equation, that's the last one now. Let's bring down our first equation, which is v is equal to u plus at. In this case, you make t the subject. If you make t the subject, you get that t is equal to v minus u over a. Now let's bring back from equation 2 now. Equation 2. Let's bring back our equation 2, which is S is equal to u plus v or t over 2. So now you're going to substitute this, you're going to substitute this in this place. We're going to substitute it here. That's t is equal to v minus u over a. So you are going to, instead of writing t here, you are going to put v minus u over a. T is this value, so you put it where you have t here. So that will give us S is equal to u plus v, okay, over 2 in brackets v minus u over a in brackets. Now we'll do simple expansion here. S will be equal to v times u will be uv, right? Then u times u will be u squared, Then v times v is v squared, and v times u is uv, all over 2 times a is 2a. So if you rearrange this, you get, put uv and uv together, you have uv minus uv, okay, minus u squared plus v squared, all over 2a. So this will cancel this out. uv minus uv is 0. So you are left with S equal to minus u squared plus v squared over 2a. So if I do a cross multiply, as usual, I'll get minus u squared plus v squared will be equal to 2as. Now, having arrived at this, I'm going to move this to the other side by simple algebraic method. So just move this to the other side. I'll get this left alone here. V squared will be equal to, this crossing to this side becomes plus u squared, okay, plus 2as. So that's the the fourth equation. V squared will equal to u squared plus 2as. So that's your equation 4. That's all for now. Don't hesitate to send in your questions and observations. See you again in my next video. Have a nice day.